graph an absolute value function, we're going to be doing things compared to parent graphs. So remember, parent graphs are in notes 1.1 and 1.2. We had 4 parent graphs, the constant function, which is a horizontal line. That one's pretty boring. We can move it up and down, and that's about it, right? The linear graph, which chapter 1 does include linear functions. We're going to look at linear functions tomorrow. So those are slanted lines. The absolute value graph, which we've been spending some time with along with the linear, so that's what we're focusing on today. So anytime you see absolute value in your function, you know it's going to be what shape? A V shape. Okay? And remember in your notes back in 1.1 and 1.2, you should be familiar with that parent function for the V, like where the points are when you made tables of values with your group members. So if you're graphing f of x equals the absolute value of x, you'll have a point at 0, 0. That's your vertex. And then to the right, if you go right 1, you go up 1. Right 2, you go up 2. And that continues. If you go left, you go up 1, left 1, up 1, left 2, up 2. And that's where we get our V shape. So you kind of want to be familiar where those points are on the parent graphs. And we're going to talk about the transformations we see in the equation and how that would translate to the actual graph. So let's look at the first box. F of x equals negative absolute value of x minus 2 plus 3. Okay. So over here, you and your group members talk. Describe the transformations from the parent function y equals absolute value of x. So what kinds of things are happening to the graph?
Right, it's going up 3 up. Yeah.
Oh, we know.
Careful. If it's a plus 3 on the outside, it'll be like a value, which means up and down. So which one will be left and right? So this one is x, right? Okay, these are the things I'm seeing as I'm walking around and spying on papers. Right 2, up 3, reflect in x-axis.
Wait, why would it reflect in the x-axis? Like, wouldn't it have to be inside the axis line?
No. So, reflect in the x-axis. Remember in function notation is negative f of x, negative y. Because if you're in quadrant 1, you're a point, and we reflect you in the x-axis, you're going to flip down into quadrant 4. So what part of your point is going to change? The y-coordinate. So in the absolute value function, that means it's going to look like negative the absolute value of x. Okay? If it's a reflection in the y-axis, that's when you would be flipping from like the first quadrant to the second quadrant, and then your x changes. So in absolute value, that would look like absolute value of negative x, but what's the absolute value of negative x? Just the absolute value of x, right? Because think about like I'm that V shape that's up here on the board. If we reflect this in the y-axis, does it look any different? No. So reflections in the y-axis will still be V-shapes that open up. Reflections in the x-axis, when you have negative out in front of the function, those are going to be V's that open down. Okay. So we're going to take our vertex point right here at 0, 0, and we're going to do these slides. We're going to go right 2 and up 3. Right 2, up 3. There is no stretch or shrink. Do you agree? Yes. So in the absolute value function, the slopes or the rate of the change on the two V's are going to be the same, like 1/1. Okay. But because we have the reflection, instead of having our V open up, we're going to have our V open down. Okay. So from this vertex point, I would go down one, right one, down one, right one. Okay, as many times as I want. And then on the other side, down one, left one, down one, left one. Pretend I went through my points. Voila! An absolute value graph that has been shifted, that's been reflected in the x-axis, so it opens down. It's been shifted right to it up here. All right, let's talk about domain and range. Domain, we've said this from our summer packet review, is all of the inputs or the x's of a function. So are there any x's that you're not allowed to take absolute values of that you know of? Is there any rule about absolute values? No. Could I take the absolute value of positive numbers? Yes. Negative numbers? Zeros? Fractions? Yeah. So all numbers will work for x. We're going to say x equals. Have you ever seen this double-sided R? It's all real numbers. Ampad, did you have a question?
No.
You can use the double-sided R. I just go double side, make an R. Okay, for all real numbers. And that should be true for all of our absolute value functions, right? We're never going to have an issue with domain because we can take the absolute value of anything we want. Okay? Now, range we talked about in preparation for the summer packet quiz is your y's. It's your up and your downs. Can you get all y's on the graph out of this function? Bo, you're saying no because you have a what?
You can't go above your vertex.
Yeah, you can't go above your vertex. That's like a maximum point, right? So what's the highest point you can be? Looks like 3 for y. So we're going to say y's that are less than or equal to 3. Excellent. Okay, so that's domain and range. Your domain will always be all real numbers for absolute values. Your range will be y's greater than or less than or equal to, just depends on whether it's opening up or down, whatever your min or max value is, which is your vertex, like Bo said. Okay, and then what's the ordered pair for your vertex? 2, 3. Okay, I'll do number 2 with you because it's got vertical stretch. Okay, and then let's see, what do I have on the back? I'll maybe give you a chance to try 3 on your own with your group and see what we can come up with. So let's talk number 2. I've got a vertical stretch of 2. How do I know that's a vertical stretch and not a horizontal stretch or shrink? Someone said? It's not what? It's not by the x. It's not inside the absolute value, right? It's just like Delaney's question about how did I know it was a reflection in the x-axis? Because the negative was in front of the absolute value. Okay? If you have a scalar that's in front of the absolute value, that's vertical stretch or shrink. If you have a scalar that's inside the absolute value right next to the x, that's a horizontal stretch or shrink. Right? So this one is greater than 1. That's a vertical stretch by 2. And we also need to move it right 1. Okay, so I'm going to take my V, my vertex has 0, 0. I'm going to go ahead and move it right 1. Plot a point. To vertically stretch it, remember, know what you know about the parent function. So like normally for all the points on the right side of this absolute value, I can go up 1, right 1. Up 1, right 1. Up 1, right 1, because it's got a line for the side. If I'm vertically stretching that, am I going to be multiplying the up 1 or the right 1 by 2? The up 1, because that's vertical, right? So now to get to my other points, I have to go up to right 1. I'm only stretching the vertical. So I go up to right 1, up to right 1, up to right 1 as many times as you want. And then on the other side, up to right left 1, up to left 1. And then I can draw my V. Does your picture agree with what you think should happen to a V if you vertically stretch it? It's getting skinnier. Yeah, remember, think about your face in Photoshop. If you just pull on the bottom, your face gets long and skinny. If you vertically shrink it, your face gets wide and fat. Cheeks have nowhere to go but out. Okay, what's my domain? X. Domain is always, yep, don't overthink it. You're never going to have an issue. You can take the absolute value of any number you want. So your domain is going to be x equals all real numbers. What's your range here? Y? Greater than 0? Or equal to 0, right? You can be on that point that's at the vertex. And what is that vertex point? 1, 0. Awesome. Okay, can you guys try with your groups 3? I'll be walking around peering at your papers and I'll kind of put stuff up as I see it happening and you can look up at the board and check it as we go. And have your group call me over if you've got like a big discussion and you need some assistance.
Just try my brain.
I feel like I'm getting
So
up.
my brain is
Yeah, it would be up and over 2. So it should be over 2. Up 1 equals 0. Yeah, because that's the one where you're going. Then you can go up 1 over 2.
That's what I thought. I was thinking.
No, right? If I got that right.
I know, but I'm
Yeah.
And see where our class was the most difficult people.
Struggle to survive.
It's like, okay, we get it.
So like you can think about like working on the graph, right? You go up 1 right 1. Right side. So you're vertically shrinking.
It's in the manuals.
Right 1. Right 1. That's really like up 1.
I was
Went up a half quadrant, right? And then over.
This one.
Either do that. Like two buttons. The back is 1/2.
Oh.
No, I'm on. Yeah. I'm not.
I spelled horizontal.
Are we doing 4 too?
We'll do that one together. It's got that horizontal.
Okay.
So. Okay, I'm gonna talk about graphing with that vertical shrink. So as I walked around, you guys did really well with transformations. Right 3 down, or sorry, right 4 down 3, vertical shrink. Make sure you have shrink on your paper. Vertical shrink by 1/2. Okay, so let's hear from groups. How did you tackle vertically shrinking your absolute value by 1/2? Maddie?
We instead of like for the when we vertically stretched it, we went up 2 over 1. This one we only went up 1 over 2.
Okay, up 1 over 2. So up 1 over 2, up 1 over 2. Do that on the other side. What happens to your v? It looks wider than the parent function. Okay, did any groups do it differently than up 1 over 2? In fact,
I accidentally went up a half and then over 1, but that's like.
which is fine, right? If you think about the way I described vertical stretch, normally right here in the parent function, we're going up 1, right 1. So when we vertically stretched it, we multiplied the y by 2. We went up 2, right 1. If we're vertically shrinking it, then we would just want to go up a half, right 1. And notice this. I'm going to do this one in red. Maybe you'll be able to see it. If I start at this vertex, if I go up a half and right 1, I'm that point right there. And then if I go up a half and right 1, I'm the point you guys plotted when you did 1 over 2, right? It takes me 2 units right to go up 1 if I'm scaling my vertical jump down by a half. So you're going to get the same answer. Either way is right, whatever you feel more comfortable with. Domain, x equals all real numbers. Range, y's that are greater than or equal to -3, and your vertex should be at 4, -3. Okay, feeling pretty confident with those graphs? Okay, let's do number 4. That one's got that 1/3 on the inside with x. So this is a what? Horizontal stretch. Remember, it looks like the opposite of what it is. It looks small, but it's actually stretching it by a factor of 3, the reciprocal. When you put it in or take it out, you got to use the reciprocal. Any other transformations?
Reflection
Reflection?
in the y or x.
X-axis. Why do you know it's the reflection in the x-axis? Because the negative is outside, in the front. Okay, outside of the function. Okay, so that's a reflection in the x-axis. Okay, what does that mean for your v if you're reflecting it in the x-axis? Your v is going to be upside down. Okay. There's no left or right movement, so my vertex is going to be right there at the origin. Okay, 0, 0. And then think about horizontally stretching it by 3 or doing 1/3 times your x. If you normally go for this parent function, if we're normally going up 1 and right 1, what part of that is going to change if we're horizontally changing the graph? Well, it will be the x or the y if it's horizontal. It'll be the x, and we're multiplying all of the x's by 1/3. So instead of going over 1, I would just be going over 1/3, which is a little bit in between. Okay. So I'm going to do it like this. This is kind of like what ANFAT did on the vertical stretch and shrink. I'm still going to go up 1 because the vertical isn't changing, right?
Wait, we're going down.
Oh, going down. Thank you. I'm going to go down 1 because the vertical isn't changing, but it's reflecting. But instead of going right 1, I'm just going to go right 1/3. And then from there, I would go down 1, right 1/3, which I'm still in between 0 and 1, aren't I? I'm at 2/3. Yes. And then I'm going to do that one more time. So then I'm going to go down 1, right 1/3, and I'm at this nice point, 1, -3. So like Alex and Lauren were saying, if your horizontal stretches by 3, but that doesn't.
Down 3 over 1 instead of down 1 over. Oh, I see now.
Yeah, if we horizontally stretch it, it should be getting wider, right?
Yeah.
Yes, it should be down 1/3. I'm gonna try and think about this.
Yeah, I was right too.
Wait, what?
Right?
Exactly.
Oh, yeah, it's still down.
It is down 1/3.
Yeah. I was right. I thought I was wrong.
Well, doesn't the 1/3, like having your 1/3, doesn't that just
Imply that it's 3. Yeah. So, okay, so maybe we should be thinking about, everybody seems to be catching on to like the slope of 1/3, so down 1, right 3. So let's leave it as that for right now. I'm going to think about this and find a better way to explain it. I don't want to like keep talking and then confuse everybody. Okay. But if you think about it, if you horizontally stretch the absolute value, it should get wider, right?
So how I thought of it
Yes.
is there's like if you're stretching it vertically, it would be going up more. But if you're stretching it horizontally, it would be going out more. And then if you shrink it horizontally, it would be going in more.
I love that. Yes. Like that should make sense, right?
Yeah.
So every time you do one of these graphs, you should be able to look at it and be like, does that make sense? And we were looking at what Ms. Cronky was doing and we were like, no, that does not make sense. So we got to readjust it. I got to think of a better way to describe that, and I'm sorry that kind of caught me off guard. So I'll talk about that tomorrow when we go over homework. Maybe you already have domain range filled in, right? X equals all real numbers, y is less than or equal to 0, and vertex at 0, 0. Your homework is a worksheet.
Yay. I like worksheets. I like worksheets. I gotta grind this out real quick. Bake them.
Yeah, I'm good this time.
Okay, so I'll come around tomorrow and take a peek at your worksheets. My meme for today is that sad looking face when you forget there's a backside. So turn your worksheet over and look at that, there's a backside. Okay.